Hello everyone, this is NEET Physics Basics by Master Prashant. Last class we discussed about the Coulomb's law of friction, what is the formula of friction and formula of friction in slip, no slip and impending slip. In this class we are going to see about some special features of some special points of the friction formula. We see the friction formula mu s when it mu s n when it is impending slip, when it is slip, it is a mu k n. When it is no slip, it is less than the mu s. It is less than the mu s. Now we are going to see generally mu k is less than mu s. Mu k is less than mu s. It means that the friction is an adhesive force. The friction is an adhesive force, which means there is a bond or adhesive. It's an interaction between these two bodies. When the body starts to move, it's go on moving, and there is no adhesive force. So there is a lot more energy, more force is needed to destroy this or disconnect this adhesive force. So the mu k is less than mu s, which is mu s. In the impending slip, what is the force in impending slip is higher and lesser in the slip, because in slip it's moving, so there is no adhesive force. But in the impending slip, there is an adhesive force. We have to disconnect the adhesive force, so we have to give more force. Then the body starts to move. There is no contact or adhesive force between this, so the mu k is less than mu s, and the mu k and mu s are independent of relative velocity of the body in contact. They are independent of relative velocity of contact, but they are dependent on the surface of contact. It means that when there is a cement surface or there is a glass surface, the difference will be the friction, adhesive force will be less. In the glass surface, the body you can easily move, but in the cement surface it's difficult to move the body. This is the difference. Difference in the difference changes in the surface contact. So this value is dependent on the surface of contact. We took the same example as the block. We will take this example in many classes. Now this block is in the state of translation. Now when we see this in the formula or the friction, we will see this as a point particle. We will see this as a point particle in the friction, or in the sums. We will see this as this block as a point particle. Now we have the normal force from the ground. This is always at the center. This statement will always be true, but it will change. When there is a rotational equilibrium, this will be changed. The normal force will not be at the center. It will be changing from it changes to any other position. This is in the rotational equilibrium. We will see that in the after few more classes. But now the n force is acting on the center. Once again, we remember the formula for friction. The value of friction. The value of friction is less than mu sn in the no slip. It's less than mu sn in the no slip, and it's equal to mu sn in impending slip. It's equal to mu sn in the impending slip, and it's equal to friction is equal to mu kn in the slip. Mu kn in the slip. But the most common mistake done by the students are, if there is a friction, they blindly put as mu n without stating s or k or s or less than s. They will blindly put that as a mu n. So we should not put that. If if there is a case of no slip, impending slip, you have to see that, and we have to put the formula like, put the value is like this. And in this no slip, it is always less, there is no equivalent, so we should give the value of friction in no slip as less than, there is no equivalent for value, so we have to do as less than Sn, mu Sn, we have to give mu less than mu Sn. And thanks for watching. Please subscribe my channel for more videos. See the end screen.